All right, welcome everybody. Let's go through chapter 6, the normal distribution. So before we actually go through chapter 6, there are just a few things we'll review. But the first thing that we should do is when we have the notes for chapter 6, if we take the final 2 pages, we'll have the Z table. That'll be really important to us. So what I'd like you to do is just keep these 2 papers towards the end and just put it to the side for now. Okay? So let me fix the camera angle. Let me adjust this over here. Okie dokie. So here, let me make this nice and fit. Okay, so here, hi all. This is your math professor Farhad Gajari, aka G Money, speaking to you through this guide. Instead of copying everything down like robots into the notebook, I typed up and printed everything for us so we can go through the chapter together. So there are some notes before we get to the juicy part of this section, so be patient. Okay, so here, let's just kind of go through this guide. There are going to be a quick 3 to 4 minutes of notes, and then we could actually get to the lesson of a normal distribution. So here, let's look at the first section over here for the first page. Here, we're going to just quickly review the 2 ideas of discrete and continuous. If you want, try and pause the video. And what was the difference between, we've covered this topic before, what is the difference between discrete and continuous? You know, try and pause the video, and if you want, read through the example so you get a better feel for it, right? But the idea with discrete is that we're using whole positive 0 and positive whole numbers, such as 0, 1, 2, 3. And when we think about continuous values, we're thinking about everything from the number line. So here, some examples like, let's say, weight, temperature. Notice that for these values over here, we could have a weight of, let's say, 154.56 pounds or something, or like 97.3 degrees Fahrenheit. So notice that we're allowed to have any real number within a continuous within a continuous section, and here discrete, we're only talking about whole numbers. So the idea for today's lesson is when we talk about normal distributions for today's lesson, we're only going to be focusing on continuous values. So values that have some sort of that could represent some sort of decimal notation. Okay. Here, when we look at many continuous variables, we have distributions that are bell-shaped or normally distributed. Let's take a sample of 100 random women and calculate their heights. Our data should look like this, right? So notice that this will have some normal distribution where the mean, median, mode will be at the center here, and we'll talk about that soon. So we call these bell-shaped curves, or also Gaussian distributions, named after the German mathematician Carl Friedrich Gauss back in the day. And yeah, okay, so we're going to be talking about these types of normal distributions, right? And we've also talked about this before in chapter 2, but notice that a normal distribution will have it fit nice in the center over here, and then we had like a skew left and a skew right. We're not going to be talking about these 2 types of graphs. We're only going to be focused on this one over here, okay? And if you want, you could read this on your own. Over here, you could also read this on your own, but these are the basic notes for the topic. I mean, this is just being very technical. We don't need to go through the technicality of it. We could do that in class together, but here for the video, I wanted to show us the actual idea of how can we use normal distributions to find areas under a z value. And I'll explain that for this part here. The idea for this lesson is finding areas under the standard normal distribution curve. So here there are some steps for it, and just a quick little review of this z-score over here. I'll just have this here, that when we talk about some z-score, yeah, so some z-score, we had for a sample, we had our z is equal to x minus x bar over little s, and remember for population, that we had some z equals x minus mu over sigma, right? And don't you remember that x bar and mu represented the mean? The x value represented the data value. And here, little s and sigma represented the standard deviation. Okay. Yeah. And here, what does our graph look like? Our normal distribution will have something like this. And usually we had like x bar or mu at the center here, right? But we could also state that this value is 0. And this is like 1 standard deviation, 2 standard deviations. This is -1 standard deviation, -2 standard deviations to the left. And the idea for this lesson is, let's say if we have some value of let's say if we had let me show this real quick. Let's say if we had like 0.5, right? Where we have a z-score of 0.5. What is the area to the left of this? What is the area to the right of this? And how do we actually find those data values? So that's the general idea of the lesson. So let's actually go through an example problem to explain what on earth am I talking about over here, okay? What we'll be doing is we're going to be finding areas to the left, areas to the right, and the areas in between, okay? So let's just take a look at the first example problem together. And this is where we get to the juicy part. Here, a bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis, a disease causing bone to become more fragile and more likely to break. The result of a bone density test is commonly measured as a z-score. The population of z-scores is normally distributed with a mean of 0 and a standard deviation of 1. So before we even do anything, let's draw a picture of what we have, right? So notice that the first thing we read is that the first thing that should pop out is the z-score is normally distributed. So the second you have a normal distribution, you have to think that I have this visual. Okay, this is the visual I have. This is some normal distribution, and our center is 0, and I have 1 standard to the left, 1 standard to the right, and 1 standard to the left. Okay. So now these test results meet the requirements of a normal distribution. So we have this normal distribution. Now what the question is saying is find the probability that a person that we take has a bone density score of less than 1.99. So notice that if we have some normal distribution, if this is 1, this is 2, the question is, okay, let me zoom in a little bit. Okie dokie. The question is, if this is the center, right? And if we have, let's say, 1.99, find the probability that a person has a bone density score less than, so here we're going to show everything less than 1.99. And one important thing that I should have mentioned in the beginning, that if we have some normal distribution, right, the area under this curve, the area of the whole entire thing is 1, okay? Because our probability for the whole population here is 100%. So like consider the whole area under the curve as 1. What we want to do is we want to find the area to the left of 1.99. Okay, so I sketched it over here, but I also drew or presented this for us over here on the next page. So what we want to do is, if we have this normal distribution, we want to calculate the area left of 1.99. And what we could do is, here, these last 2 pages where I told you to hang on to the side, what this shows is the areas left of a normal, of a certain z value. Okay, so here, this shows area to the left of any given z value. So for example, here, our z value that we're trying to find to the left of is 1.99. So if we actually look within these 2 charts, we could actually locate 1.99. Let's find that number of 1.99. And notice that one of the sheets should have positive values, and these positive values represent the z values to the right of 0. And here, within the negative z values here, these are the z values to the left of 0. So notice that this 1.99 is positive. So what we want to do is, and how do you actually read what this is? Here, notice that if you look at the left column over here, notice that you have 0.0, 0.1, 0.2. So let's go to 1.9, right? So notice that this is 1.9 over here, okay? And now we have we have 1.9 over here. Now to get the other 0.09 with what we need, it is on, oh wait, let me fix the resolution a little bit. Notice that this value here represents 1.90. This value over here represents 1.91. 1.92, 93, 94. So we want to go all the way to 1.99, and this value is, let me just make sure, is this right here. It's 0.9767, okay? And notice that, how did we find that? We found that with the intersection of 1.9 and 0.09. And what I did was I showed a little I showed a little description right over here on how to do it. And so notice that they intersect at that 0.9767. So what does that 0.9767 represent? So let's see. What does this represent visually? If you want, pause the video and just think about it. This 0.9767 represents the area to the left of 1.99. This whole entire area right here, because the whole entire normal distribution is 1. So what's the area left of this 1.99? It is 0.9767. Okay. Now here, to continue on, let me see. Yeah, this is here. Let me just organize my notes. So here, yeah, here I just kind of did everything step by step. So the whole normal distribution is 1. This 0.9767 represents the area to the left of 1.99. So thus the probability of a z-score below 1.99 is 0.9767, or 97.67%. So what does this mean in the context of the question we were actually looking for, right? That there is, if we read it again, find the probability that this person has a bone density score of less than 1.99. The chance of someone having that is a 97.67% of people. I'm sorry. The chance of someone having this bone density below 1.99 is 97.67. Okay. And that's the idea of this lesson. Like, we wanted to find the area to the left. Next, we're going to find, we found the area to the left, yeah? The next one we're going to find is area to the right. So here, let's take a look at the next example. Let me make sure I have everything organized. My two z tables are there. Okay, let's take a look at example number 2. So using the same scenario with the same bone density, find the probability that a randomly selected person has a result above -1. Okay, so what I want you to do is, even before we do anything, try and draw this visual representation. So if we have a normal distribution, okay, the center is 0, and where are we looking at? We're looking at -1. So -1 is here. Now the question is saying, find the probability that a randomly selected person has a result above -1. So notice that we want to find this area over here. Okay. Oh, sorry. I'm realizing that the resolution is very bad. I'm sorry. Okay, that's right. So here we want to find the area to the right of -1. So how can this z-table or z-chart help us find that? So if we take a look, we want to find -1. So let's look at our z-chart. Notice that we're not going to use the positive values. Let's look at the negative values. Okay. Here, where is negative 1.0, it is right here. Negative 1.00 is right here. So notice that this 0.1587, 0.1587, right? What does this 0.1587 represent? If I were to have a graph and I would have a normal distribution, remember that this graph, if this is negative 1, what we just found right now was the area to the left of negative 1. The area to the left of negative 1 that represents this area right here is 0.1587, because that's what these z-tables do. They only find area to the left. They do not find area to the right. So notice that if we have 0.1587 to the left of negative 1, what do you think you're going to have to do to find this area to the right of negative 1? And hint, what's the area of the whole thing? The whole area is 1. So how would you find the area to the right of it? Pause the video and try and think about it. Okay, here I just showed that little intersection part, that 0.1587. Okay, so here, going back to that original question, what does 0.1587 represent? It represents the area to the left of negative 1. So we want to find the area above, right? We want to find this area in the green. So then how can we answer this question? The idea is, if you know the whole area is 1, this whole area is 1. This area that we just found over here in the yellow is 0.1587, right? So then how do you find the area in the green? We just subtract, we do 1 minus 0.1587. If you take the whole thing and minus it with the yellow, it has to give us the area to the right, which is this green. And here, what is 1 minus 0.1587? It should be, oh God, what is it? 8413, right? 0.8413. Okay, so then here, the area to the right of negative 1 is 0.8413, and this is an 84.13% chance that somebody has a bone density higher than negative 1. Okay, within the z square. Okay, so here we did area to the left, we did area to the right. Now what's the next thing we're going to do is find area in between. So here, let's take a look at this example number 3. Here it states a bone density test reading between a -1 and a -2.50 indicates that the subject has osteopenia, which is some body loss. Find the probability that a randomly selected subject has, oh God, that is not how you spell reading, has a reading between -1 and -2.50. Okay, so now I said use your intuition and figure it out. So why don't you try to figure this out based on this question? And what I'll do is pause the video and try on your own. Like, trust yourself. What would you do to figure this out? Okay. Okay, so here, let's try and figure this one out here. Let me zoom out a little bit. So we know the question is saying what is between -1 and -2.5. So if we know the whole area, let's visualize what we want. So here, this is some normal distribution. This is 0. This is -1, and this is -2.50. So here, we want the area, hold on, give me a second, let me get a glass of water.